We have started reflection, plane mirror, some of the terms related to reflection by plane mirror, angle of incidence, angle of reflection, glancing angle of incidence, glancing angle of reflection, incident ray, reflector ray, virtual image, real image, magnified image, diminished image. So these are the terms, some terms. Normal, we have learned. Terms related to reflection of light by plane mirror. Okay. So now reflection of light by curved mirrors. The topic is reflection of light only by curved mirrors. Today, it will be like a practical kind of class. I will be giving you some instruction and some time also I will be giving you in the middle, and you have to send the screenshots of the experiments. Okay, I will be telling that instruction now. So today we will be learning reflection by curved mirrors. Mirrors, I am talking about mirrors only, and I am talking about reflection only. I am not talking about anything refraction. Arundhati and Nilanjan, I will come to that after this. Okay. So first of all, how we have learned in the plane mirrors some terms related to reflection in the case of plane mirror. In the same way, for curved mirrors also some terms, let us try to understand. Okay. Then we shall go for some practicals, some simulations. Okay. So there is something called center of curvature, CC, center of curvature. Actually, these spherical mirrors, see, this is one of the mirror, curved mirror, concave or convex, whatever it is. They are the part of they are the part of sphere. They are the part of sphere actually. Okay. So yeah. So these curved mirrors, concave or convex, they are the part of the sphere. They are cut from the sphere. So sphere is a mathematical term. You have learned it. Spherical shape. It has some center. So that only we call it as center of curvature. In the case of curved mirrors also. And there is something called the midpoint of the mirror. This one we call it as pole of the mirror. Okay. So we are learning some terms related to curved mirrors. Okay. And one of the term is center of curvature. This is the actually it is a part of the sphere, so that's why it's a center. There is a center, and there is something called the midpoint of the mirror, and that is called as pole. Okay, we indicate it with P, pole. And there is a line or axis which is which joins the center of curvature and pole. We call it as principal axis. We call it as principal axis. Okay. Can you see my annotations? Whatever I am writing, can you see those?
Yes, sir.
Yeah.
Yes, sir.
Center of curvature, pole, and the line drawn through the center of curvature and pole, we call it as principal axis. Okay. And we have also understood last class concave and convex definition we understood. I hope you remember. Concave and convex. What do you mean by concave and what do you mean by convex? And based on that we can define this focus, focal length, all those. So can anyone repeat once? Concave mirror means? Concave mirror. Can anyone? Concave mirror?
So whose inside curvature is reflecting?
Yes, very good. Whose inner surface is a reflecting surface? Concave. I told cave. Cave means inner, something which you have to go inside. So that inner surface is a reflecting surface. We call it as concave mirror. And if outer surface is a reflecting surface, we call it as convex mirror.
Mirror.
Okay. So on the screen you can see concave mirror. See, here is an object and there are some rays sending on the inside inner part of the mirror and they are getting reflected. Okay, so from here it is going and getting reflected, and from here it is going and getting reflected. Okay beta, inner side it is
Sir,
incidenting. Yeah,
sir, is the focus the middle point of the principal axis between the center of curvature and the pole?
uh, center
So
of,
because in some books it is written that the focus is the total center.
actually there is one more focus. No, no, we cannot say like that. No, no, we cannot say. That is wrong.
Means it is given that 2 into focal length is equal to the principal axis between the center of curvature and the pole.
Uh, 1 minute.
Yes, sir.
There is
Yes,
something
sir.
called focal length.
Yes, sir.
Focal length is half of the radius of curvature. First, please, step by step, let us go. Wait, you wait. Okay. So inner surface, when you are incidenting the rays, okay, on the inner surface, which are parallel to the principal axis, they go and hit. They meet at a point called focus. Okay. They meet at a point called focus. So once again, we understood center of curvature, we understood pole, we understood principal axis. Principal axis is the line which is passing through the center of curvature and the pole. And we understood like one more thing, focus. So whenever you send any parallel rays onto the mirror, they reflect and they meet at a point. Okay, that is called focus. They reflect back, they rebounces back, and they meet at a point on the principal axis called focus. Okay, and there is a one more term, the distance between the pole and focus. The distance between the pole and focus, we call it as focal length. We indicate it with small f. Small f. Okay, we indicate it with small f. The distance between the focus and pole, we call it as focal length. We indicate it with small f. Focus, we indicate it with capital F. We will also say focus or principal focus, both are same only. Okay, and Samir doubt is, sir, can we say that focus is the meeting point of the reflected rays? We cannot say the meeting point of the reflected rays. We have to add one more term. It is a meeting point of the incident parallel rays. Okay, sorry. So when you send parallel rays, parallel incident beam, then and that parallel for what? For the principal axis. If you send a parallel beam, they get reflected back and meet at a point called focus. But if you send rays through focus, through center of curvature, they will not meet at a point, they will not reflect. They may reflect, but they will not meet at a focus. Samir, is it okay, Samir?
Yes, sir.
Yeah. So,
So, sir, can we say that the focus is the meeting point of parallel incident beam?
yes, yes, yes.
Okay, sir.
Focus is the meeting point of reflected rays by the incident parallel beam. Meeting point of the reflected rays by the incident parallel beam. When you send incident parallel beam only, they meet at focus. Okay, Samir?
Yes, sir, clear.
Yeah.
Sir, this is the case with concave mirror only.
Uh,
No, sir, in
Sir, this
convex
happens only
also.
with concave mirror.
in convex also little bit different type of definition, but the what we say,
Sir, the what you mean?
you have to send the parallel beam only. You have to send parallel beam only. Okay, but focus definition is little bit different in the case of convex mirror. I will come to that. Please little you wait for a while. Arkaprava.
Sir, virtual focus.
Yeah, yeah. I will come to that. Please wait. Once again, I repeat. First, we understood center of curvature. Actually, curved mirror is a part of a sphere. So every sphere has one center, and that is only center of curvature. And next we understood pole. Pole is the midpoint of the mirror. And next we understood principal axis. That is the line drawn through center of curvature and pole. Okay. And there is one more thing called radius of curvature. Radius of curvature means from center of curvature to any point on the mirror, that length we call it as radius of curvature. For circle also we define radius na, from center to any point on the circle, that is radius. In the same way here also, from center of curvature to any point on the curved mirror, we call it as radius of curvature. Okay.
Sir, I cannot understand radius of curvature.
Radius of curvature means from center of curvature to pole distance, we call it as radius only. From center of curvature to any point on the mirror, we call it as radius of curvature only. Is it okay, beta? Samir?
Okay, sir, understood.
It is just like a circle. For circle,
Sir, it's like radius of a circle.
oh yeah, yeah. We define for circle in the same way. It's a geometrical concept, and we are using it in the physics. Mensuration, I think mensuration, in mensuration you study all these things. Okay. And one more thing, we learn focus. When you send incident parallel beam, they reflect back at and meet at a point called focus. Okay, that is number one. Number 4 point. And focus to pole distance. Focus to pole distance, we call it as focal length. Focus to pole, the distance between the focus and pole is, we call it as focal length. And as said by Sai Krishna and one more Samir, they said that R is equal to 2f. R is radius of curvature and focal length is small f. So there is a relation, R is equal to 2f. So from there they are telling that focus is the midpoint. So let us see if I acha. Yeah, if I make it into 2, it is becoming 4. If I make it into 4, it is becoming, the center of curvature is becoming 8. Yeah, we can say uh, the midpoint of center of curvature and pole is focus. Okay, the midpoint of center of curvature and pole, we call it as focus. Actually, see, focus is at 4, but pole is somehow here, na? Pole is somehow here. So approximately we can say, not exactly. Approximately. If I make it this focus at 3, the center of curvature is becoming at 6. If I make this focus at 2, center of curvature is becoming 4. But here there is a, like, from 0 to some distance is there. From 0 if you take it, is fine. But
Sir, then we can call the approximate distance.
approximately only we can call. Okay. Yeah, next. Next, Tiasa is asking some doubt. Sir, is a plane mirror a part of curved mirror? Plane mirror, beta. Plane means plane, flat. Curved means there should be some curvature. Plane mirror, curved mirror, both are different concepts. Plane mirror is a flat surface. Curved mirror is a part of sphere. Part of sphere. Is it okay, beta? Tiasa? Tiasa?
Yes, sir.
Yeah. So, finally, center of curvature, focus, pole, focal length, principal axis, radius of curvature, we have learned all this. Okay. And I think in the last class, we have done some activities related by using some spoons. Yes or
Yes,
no?
sir.
No.
Yes, sir.
Yeah. Somehow, somewhere you got inverted image, somewhere you got erect image, somewhere you got uh, magnified image, somewhere you got diminished image. Okay.
Sir, you also told to do that activity of between the angle between mirrors. That activity.
Uh,
Sir, one activity was there in our book. That the
yeah,
angle between the mirrors.
yeah. That plane mirrors, if you maintain some angle, number of images, that only, na?
Yes, sir.
Yeah. Yeah, actually,
Yes,
Arkapravan has
sir.
sent that that activity, and Sulagna has sent a periscope, and Most of you have sent that rainbow formation, and Samir, in your case, the rainbow is not formed. You have to repeat the experiment. Samir.
Okay, sir.
Yeah. Yeah, now we shall understand. Now we will understand like why there is a changes in the image formation. Like sometimes you are seeing as it is erect image, sometimes inverted image, sometimes magnified, sometimes diminished. So why there is a changes when you are looking at the spoon? Okay, so that let us try to understand. Okay, so I am taking an object, I am keeping here beyond the center of curvature. This is the center of curvature, and I am keeping my object here beyond the center of curvature. Okay, so you can see that the image is formed. The image is formed in between center of curvature and focus. The image is formed in between center of curvature and focus, and the image is inverted. The image is inverted. The image is real because actual meeting of the rays taking place. Actual meeting of the reflected rays is going like they are meeting. A real meeting of the reflected rays is taking place. So that's why we get real image, and we are getting inverted image, and we are getting diminished image. Okay, so if you keep the object beyond the center of curvature, this is the image nature of the image. Okay, and if I keep my object at the center of curvature, at the center of curvature, so what is happening? Image is inverted. Image formed at a center of curvature only. Image is same size of the object, and image is real. Real image, inverted image, forms at center of curvature only, and image is same size as that of object. Same size as that of object. Shreya, you are telling something? You are telling something, Shreya?
No, sir.
Yeah, fine.
Sir,
Yes, Sai Krishna.
so here there are some terms in like DOHI. So what does this represent as?
Yeah. DO, distance of the object. So from this point, distance of the object is 8 centimeter.
Sir, and H
DI,
means height of the object.
DI, distance of the image. It is also formed at 8. HO, height of the object. Yes, Sai is
Height of the
correct.
object.
Height of the image, height of the object. So same size, it is showing same size, 3 and 3. And inverted, you can see.
And so these numbers are using the sign convention.
Yeah. HI is equal to minus
Okay, sir.
3. HI is equal to minus. They have not used sign convention because from the pole, if you go left side, na, you have to take minus. They have not used it. Sign convention in this, they have not used it. In class 10, we will be using it, sign convention. And here HO 3, HI minus 3. Why? Because it is inverted. For this, height of the object and height of the image on the screen, they have shown the like convention, but object distance and image distance, they have not used the convention. Hi Krishna. Okay,
Okay, sir.
there are certain rules actually, that convention plus taking the minus, there are certain rules. If time permits, I will also we will also discuss that. But the main objective here is the image formation by curved mirrors. Okay, so that you have to learn. Now next experiment, like the object which you are keeping is in between center of curvature and focus. The first experiment that we have done is the object is beyond the center of curvature, and next experiment object is at the center of curvature, and third experiment the object is in between center of curvature and focus, and you can see the image is formed beyond the center of curvature, beyond the center of curvature, and image is inverted, image is real, image is magnified, image is magnified because image height is more than the object height. Okay, so image size is more than the object size. I repeat, if you keep the object in between the center of curvature and focus, and the image formed is image is inverted, image is real, image is image formed beyond the center of curvature, and image
Sir,
is
magnified.
magnified. Okay. Yeah, Arkaprava, any doubt?
No, sir. Sir, I was telling that for these ray diagrams, there are certain rules, no?
Yeah. There are rules. Yeah. Okay. Like the rules are like this. If you send the ray parallel to the principal axis, na, it reflects back at the focus. This is one of the rule. Okay. And if you send the ray through the focus, it is just a ulta, reverse of it. If you send the ray through the focus, it reflects back as a parallel ray. These are the rules. Okay. Number one, if you send the
Okay,
ray,
sir.
if you send the ray parallel ray, if you send, it reflects back at the focus. And if you send the ray through the focus, it reflects back parallelly. So these are the two rules. There is also one more rule. There is also one more rule. If you send the ray through center of curvature, if you send the ray through center of curvature, it reflects back through center of curvature only. It reflects back through center of curvature only. So these are the three rules for drawing the ray diagrams. Arkaprava. Is it fine, Arkaprava?
Yes, sir. Thank you.
Yeah. Okay. So now this third experiment is over. Now fourth experiment I am doing. I am keeping the object at focus. Okay. I am keeping the object at focus. The image is formed at somewhere infinity. Here it is given no image. Actually in this simulation we cannot see, but the image is formed at infinity. Okay. Somewhere very far away from the mirror. Very far away
Sir,
from the mirror.
virtual or real?
Huh? Shreya?
So the image will be virtual
Sir,
image because
virtual or real?
No, real only. It is real. Image is real only. Some problem she is facing actually, Shreya. Shreya is leaving the meeting. Okay, image is real only. Image is highly magnified, and image forms at infinity. image is inverted. Real images are always inverted. This is the fourth experiment. Okay. And if I keep my object in between focus and pole, if I keep my object in between focus and pole, so what is happening, you see. So image is,
Sir, virtual image.
yeah, virtual image is formed. See, the rays are reflected here back, but extended reflected rays, if you meet, if you extend the reflected rays, the virtual images will form, and that is other side of the mirror, that is other side of the mirror, and the image is upright, erect image or upright image forms, and the image is magnified, the image is virtual, the image forms behind the mirror. Okay, so these are the changes taking place depending on the position of the object. Image position is changing. So that is why when you are doing with the spoon, the image is different at different positions. When you are taking the spoon very close to your face, or when you are taking the spoon away from your face, you will observe some of the changes in the images. Okay, so last time somebody was asking, sir, will it happen really? Yes, it happens really, because so since we are changing the object position. Okay,
Sir,
yeah,
so when the object is kept at infinity, then the image will form at the focus.
yes, that experiment is also there, but I cannot keep the object at infinity in this simulation. So that is why I have not shown that. If the object is at
And sir, one more
infinity,
thing I was asking that, so there are three rules for the light rays, like if it will pass through focus, then it will be parallel. So is there any rule that if it will pass between the focus and the center of curvature, or between the focus and pole, if the light rays pass through that?
then you have to use that law of reflection, and angle of incidence is equal to angle of reflection. Like
Okay, sir.
those rays are called oblique rays. At an angle, they fall onto the mirror, and you have to draw normal, and angle of incidence you have to find out. Then angle of reflection you have to draw accordingly. Follow the law of reflection. Okay. But if you use those, we cannot explain the image formation. That's why we take some simplified rules. We take some simplified rules, okay, as we discussed, and we draw free body, sorry, not free body, sorry, ray diagrams. Is it okay, beta? Sai Krishna, Samir,
Okay, sir.
and Arkaprava, Sandeep, Srijit,
Okay, sir.
Srijoni.
Yes, sir,
Oh,
clear.
okay, sir.
Yeah. Yeah, Srishti, you are again always late only. It's not good habit. Okay? It's not good, better. Every time you are late. So now your task is, I will share this link. First experiment, you have to keep.
Sir, you have already shared this
You have
link.
already shared.
I have shared link. Okay. So first experiment, I will keep. You have to keep object at beyond center of curvature. Number 2 experiment at the center of curvature. Number 3 experiment between center of curvature and focus. Number 4 experiment at focus. Number 5 experiment at focus, in between focus and pole. So these 5 experiments you have to practice now, the simulation experiments, and you have to send the screenshots now only. Okay, now only.
Sir, please send the link once more.
Yeah, I am
That is
sending
not
now.
in my
I am
laptop.
sending now.